What do you think of when someone says the word math? Do you think of algebra or geometry? Or maybe you think of simple addition and subtraction. Nonetheless, math is so much more than a required high school class. Think of a song you like. It can be any genre of music, and just imagine it playing in your head. Now think about what you can hear within the music. Is the song fast paced? Does the pace change? Does the singer jump octaves while they sing? Surprisingly, all of this is related to math.
One common thing between math and music is that both of these things use patterns. In music, a common pattern everyone knows is a chorus, which repeats itself multiple times in a song. In math, patterns are used to explain and predict the unknown. Professional mathematicians use highly complex algorithms to find and analyze patterns within mathematical sequences and even use these algorithms to predict crime and the potential aftermath. Musicians tend to also use patterns within notes to look for familiar notes and notes that appear less often.
When you look at a piece of music, you will see numbers nearly everywhere, and not all of them are in plain sight. There's measures, time signatures, and notes, and only two of these will have visible numbers, but all of them have to do with math. Measures have equal beats in each section as the time signature states, and these are simple divisions of time. Notes themselves are numbers in disguise. Each note has a specific number of beats, or how long the note is held, and all its numbers that are very important for a musician to understand in order to count the music correctly. Counting music boils down to a simple addition of beats per measure. Intervals are one of the most mathematical things in music. Pythagoras found that if you take a string and divide it in half, you will get a different octave when the string is plucked. An octave is one of the many musical intervals. Like the perfect fifth, this means that intervals will have different ratios, but the octave has a ratio of 2 to 1, and by using simple fractions, Pythagoras developed today's musical scale.
The last thing I will be talking about today is frequencies. Frequencies, like intervals, include quite a bit of math. For example, frequencies and music intervals can create math equations. Frequencies of notes can be multiplied by interval ratios to find a new note to create the interval with the beginning note, such as a perfect fifth. An example of this would be to take the frequency of the note A in the octave 4 and multiply it by the ratio for a perfect fifth. The note A4 has a frequency of 440 Hz, and the ratio of a perfect fifth is 3 to 2, or 3 over 2. From there, it's a simple multiplication equation to find the perfect fifth. The equation 440 over 1 times 3 over 2 can be used to find the perfect fifth from A4, which is the note E in the fifth octave, which has a frequency of 660 Hz. This math would normally come into play if a musician was tuning their instrument, but it is still important to make sure the frequencies are correct so the notes sound well with each other.